Hi everyone, I'm Velankani Joyce Divya and my teammate Maunika Paidi. So our project is on Conway's Game of Life. We'll look into the introduction. So talking about the project overview, the project aims to provide an interactive and visually engaging simulation of Conway's Game of Life, a well-known cellular automaton. So this simulation will feature a dynamic as well as user-friendly grid, which allows users to experiment with various starting patterns and observe their evolution over time. So this system also integrates both a responsive front-end interface for seamless interaction, and also we have implemented a robust backend for and handling user sessions and ensuring smooth gameplay. So our primary goal is to offer enjoyable and educational experience, so which allows users to explore the principles which are behind this game of life in an intuitive manner. So by enabling users to create, control and observe complex life patterns, this simulation will help deepen understanding of cellular automata and also the behavior which is associated with it, which can be produced. So, whether for educational purposes or simple entertainment, this project aims to make the mathematical model accessible and interactive for all users. So, while doing this project, we have faced few challenges, and the challenges faced are as follows. So, Conway's evolution rules. So, accurately implementing Conway's rules for cellular evolution, where like each cell's state changes based on its neighbors, is central to the simulation. Ensuring these transitions occur correctly, especially for large and complex grid configuration, has been a significant challenge. And the next challenge was regarding the state transitions and performance. So, the simulation needs to handle frequent state transitions efficiently. So, what happens is even when dealing with complex or large grids, maintaining smooth transitions without log or delay, especially when visualizing millions of possible states, it changes with real time. So that has been also a key significant challenge. The next one is real time visualization. So a crucial aspect of this project is providing real time updates of the grid with minimal latency. So the challenge lies in displaying updates smoothly, which and also ensuring that the users can follow the evolution of patterns without any interruption or slowdowns, even as as the simulation progresses through multiple generations. So this project will ultimately allow users to immerse themselves in this evolving world of Conway's Game of Life, and this offers both a learning experience and also it is a source of endless experimentation. So next is tech stack. So talking about tech stack, we have used HTML, CSS, JavaScript, PHP. So HTML5 for structuring the application's user interface, creating the grid layout, and ensuring compatibility across various devices and screen sizes. CSS we have employed for styling the grid cells, representing alive or dead states, and implementing smooth transitions, contributing to overall visual appeal of the simulation. And the next is JavaScript. So, central to the simulation logic, this manages real time grid updates, handles user input, and controls interactive elements such as play, pause, and reset. PHP is for managing the backend logic and handling database operations, ensuring smooth data storage and retrieval for user sessions and game state persistence. We'll go to the next slide. So this is the project structure. So we front end and back end. So database, SQL. Talking about the front end, we can see on the right hand side we have CSS, styles.css, JavaScript. We have three JS pages, which is admin, auth, and game, which about which we'll be looking into detail. So, and followed by dashboard, admin.html, index.html, jQuery, that is a default file, and login and register. Next, talking about backend, we have admin, config, load patterns, login, register, and save game. We'll be talking about each of these in detail. Next. So, about the game feature, so it is a dynamic and interactive cellular automaton where users can observe the evolution of cells based on Conway's rules. And the simulation runs in real time, showcasing how initial patterns evolve through multiple generations. Users can start, pause, and also reset the simulation for different experiments. So, the key highlights of this is real time cell state transitions, alive or dead. It also explores the fundamental principles of cellular automata. Yeah, next. So talking about the HTML and CSS, so the logo and header. So we have used a logo and a header. The login form contains username and password input fields with a login button. External link links to an external CSS file for styling. And CSS, flexbox, logo styling, button styling, and input fields. Next. Admin.js, it is basically used to manage users. So manages user operations like view, edit, delete for admin users. So the key features are as follows. Load all users. So this basically fetches and displays registered users from the backend. And we create a dynamic user interface with edit and delete options. So this edit user, it prompts the admin to update email and role of a user, sends updated info via post to admin.php. And delete user, it is to prompt confirmation before deleting the user. It sends deletion request via delete to admin.php. Next, talking about the user interface, we have two, edit button and delete button. So allows change in email and role. Delete button confirms and removes users. Response handling. On success, it reloads the user list. On failure, it shows an error alert. Next. So this is a grid-based game. So this is a JavaScript overview of game.js. We can see on the right-hand side. So the key features of this code is that it has dynamic grid integration. That is, we have created grids of various sizes, 10 into 10, 15 into 50, 20 into 20. Cell highlighting is the next key feature. It toggles cell states by clicking to highlight or unhighlight. Next is predefined patterns. We can select patterns like block, glider, gospel glider, gun to highlight cells. And the next one is random highlighting. So random highlights a set number of cells for a dynamic game experience. Next is iteration based simulation. So grid updates based on rules like neighbor count with cells dying or coming to life. Talking about the game logic, again, is based on cellular automata principles, and this follows certain rules like dying from underpopulation or overpopulation for each generation. Yeah, this is all about grid-based game. Next. Yeah, next, talking about the dashboard. So we can see on the right hand side, we have the code. We can see the grid size options being displayed as discussed in the earlier slide as well. We have various grid size options, and we have a change grid feature which updates grid size using a drop down and button. Next is generation display. So we show a current generation number. The next one is main controls. So start, increment, and reset. So start to begin the simulation with dynamic updates. Increment, we step through one or more generations manually. Reset, we clear the grid into its initial state. And the next one is pattern options. So we have predefined patterns as said earlier, like block, blinker, toad, glider. Random, we generate random cell configurations. Next, interactive elements are buttons and grid update. So buttons for manual simulation control, like the start, increment, clear. Next, grid update, dynamically we alter the state based on the chosen pattern or random cell generation. Next.
Yeah. The next module is admin module. Here, the session begins by verifying whether the user has administrative privileges, and this is a crucial security step because if the user is not an admin, then the API immediately responds with 403 unauthorized code, and if a client tries to use an unsupported HTTP method, then the API responds with 405 method not allowed error. So this layer adds a robustness, ensuring that the system only accepts well defined and intentional interactions. Another critical aspect of this API is it is role based access control. This means, like, even if a user is authenticated, their permissions are checked before granting access to certain functionalities. And the next module is patterns module. Here the main purpose of this module is to serve predefined cell structures in the JSON format. We have defined three key patterns. The first one is the block pattern. It is a static 2 by 2 shape. It is known as a still face because it doesn't change over time. And the second pattern is the glider. It is a diagonal moving shape classified as a spaceship. Also, it moves across the grid over generations. And the third pattern is beacon pattern. Here, an oscillator that blinks for every two generations. Also, it flips between two states repeatedly. So each of these patterns is represented using an array of coordinate pairs. For example, row column like 1 1 or 2 2 depends on where the pattern is placed on the grid. So here the data is then encoded into the JSON format, which makes it easy for the front end to consume and also to parse and render these patterns dynamically. So this approach keeps the backend and front end loosely coupled. And it allows pattern logic to be defined once, and it can be reused across different parts of the application. Yeah, and the next module is the login module. So the primary purpose of this module is to handle login requests by validating the username and password provided by the user. It follows a structured flow to ensure both functionality and the security. First, it receives JSON input containing the username and password, and once the data is received, the input is sanitized to protect against SQL injection. Also, after sanitizing, the system queries the users table to find whether a record matching is found or not with the provided username and password. And if a match is found, then it uses built-in PHP's built-in password verify function to safely compare the provided password. So, from the security standpoint, this module mainly uses two features. Those are password verify and the real escape string to handle security and hashed passwords. Next module is register module. Here, the main purpose of this module is to register a new user by accepting their details and also stores them safely in the database. Here, the workflow begins by accepting a JSON input like username, email, and the password. And also, we can provide the role whether the user is admin or the player. So once the input is received, then the module sanitizes the data using a real escape string, same as login functionality. And then the module constructs an SQL insert query with all the sanitized and the hash data, and then it executes into the store to execute it like to store the new users information to the database. And after execution, then the system returns a success message saying that the user has created successfully, or if there is an error, then it returns an error message like a duplicate entry or something went wrong. From the security standpoint, this module is solid and defends against SQL injection using input sanitization, and also it ensures passwords are stored securely with bcrypt hashing. And the next module is session saving. Here, we can save the number of generations a user has played during the session game. Also, this module allows to track gameplay history, and also it potentially use it for analytics or progress tracking. Here, the process starts with a session check. It verifies whether the user is logged in by checking for a session of user ID. So, if the session is not active, then the user is not logged in and the operation is not allowed. Next, the module retrieves the number of generations from the JSON input sent by the client. Then, this value represents how many generations the game ran in that session. Uh, After that, the module performs an SQL insert operation, like it allows adding a new row to the game sessions table with the user ID from the session and the number of generations played. And from security point of view, like we enforce a session based access control means only authenticated users can save their game data. Also, before inserting the number of generations, the module applies server side input typecasting. So it ensures that the input is treated strictly as an integer, and also it helps to prevent injection attacks. Yeah. To conclude this project delivers a rich, dynamic, and interactive simulation of Conway's Game of Life, and it is a classic example of cellular automata that has fascinated scientists and mathematicians. So our goal was to make this abstract concept and turn it into something visual, hands-on, and intuitive. So it is accessible for both learning and exploration. Also, the simulation allows users to engage directly with complex life patterns, and they can observe how they emerge, move, and oscillate over the time. So whether it's still lives or gliders or oscillators, user can experiment with a wide variety of configurations through this Convex game of life. And we have built this project with usability and learning in mind, and the interface is clean and responsive. It features a grid that automatically adapts to screen size, making it easy to explore the simulation on different devices. And from a technical perspective, the simulation leverages real-time rendering and also dynamic updates. It handles user interaction fluidly. Also, it ensures a smooth experience even as the number of active cells increases. So the front end is fed by the back end that delivers predefined structures like block, glider, and beacon. Those are encoded in JSON for flexibility. and this modularity allows for future expansions without rewriting the core components. So beyond functionality, one of the important aspects of this project is its educational value. It demonstrates how simple rules can give rise to unpredictable and beautiful complexity, like a core principle behind algorithm thinking, chaos theory, and even real world biological systems. Yeah, that's it. Now I'll demo the project. Yeah, this is our project. On landing, we have two options like to log in or sign up. Here, I'm signing up. I'm giving the values as M3, and I am registering as player. Yeah, here it is showing registration successful. So after registration, I'm logging in with those credentials. As I am player, I am redirected to this screen. Here we can change the grid size by selecting 20 by 20 or 30 by 30, and by clicking on the change grid. Here we can change this grid size like this. And we have some buttons like start, increment 23, reset, and the patterns like block and blinker. I'm clicking the block. So when we click on these patterns, different types of patterns comes on this grid, and random pattern generates some random pattern. And if we click on increment 23, then the generation continues till 23, and the reset button reset it to the initial one. So this is the player view, and we have admin view also. Here now I will register one user as admin. Register. Okay, next I'm logging in with that username. So when an admin logs in, then he can see all the users that were registered till that time, and yeah, they can see details like their username, email, and their role also. This is the admin dashboard. This is our project on Hyderabad. Thank you.